All right, we're back. We are on page 7 of notes 12, Calc AB. We're doing definite integrals. Last page, we did like an application thing. Now we're back to just straight up doing them kind of geometrically. I'm going to go ahead and find a lot of these areas because, usually you need them. So 0.5, I'm going to break it up how I think makes the most sense and then just kind of hope. So this region is kind of interesting. Like I would not be surprised if we have to like break it here at some point, but that's just half of the whole thing. So what I'm going to do is this, and then I'm going to add in this semicircle. So what's this? This is 4 by 2, so that's 8. And then this is a circle that has a radius of 2, so an area of 4 pi, but only half of that. So this is, the total thing is going to be 8 plus 2 pi. And let me do that again. So 4 by 2. Okay, that was good. And then a circle with a radius of 2 has an area of 4 pi, but we only need half, so 2 pi. I think that's right. Half of it would be 4 plus pi. I think we'll be able to use that. Really, really hoping that I divide this region this way on any problem that we need to do. I'm hoping, who knows. So this would be 3 by 2, so 6, and then half of 3, so 6, and so 7.5, which like you could make 15 halves, just depends on what you're doing. And then this is going to be 1.5 because it's half of 3. I'm going to divide this here. Basically, I'm just hoping that I didn't make any problems where like we have to cut this in some weird way. 2 by 3 is 6, but half and negative, so negative 3. And then I'm going to break this up to this. So that's negative 2 and then negative 0.5. All right, so I usually just dive in and get all those. And once I have them, I can use them to answer the question. So I'm going from negative 4 to 0. Negative 4 to 0. We did it, 8 plus 2 pi. All right, off and running. It's like it pays dividends, you know? What are we gonna do here? I'm gonna break it up. We've done this before. And that's, you wanna get to the point where you're looking at problems and you're like, oh, I've done this type of thing before. So the dx goes with it. And then I'm gonna say plus negative 4 to 0 of negative 2 dx. You could do minus the integral from negative 4 to 0 of positive 2. Doesn't make a difference. I mean, is it conceptually different? I guess a little bit, but like it doesn't numerically make a difference. So this is our 8 plus 2 pi. And then this will be a rectangle that has a base of 4 and a height of negative 2. So just straight up 2 pi. Interesting. Hope. So does that make sense? Oh, that makes total sense, right? If we take this graph and move it down 2 units, then we're just finding this. We're just finding the semicircle. We could have done that by thinking instead of by doing, but we didn't. All right, negative 6 to negative 4 of f prime. This better be the graph of f, by the way. Oh, it is, okay. So like all of a sudden I was like, what are we doing? Negative 6 to negative 4. All right, I'm gonna think in terms of displacement. This would be f of negative 4 minus f of negative 6. That's in terms of displacement. So let's look and see what that gives us. Negative 6 is 1 and negative 4 is 2. So what am I doing? So I'm doing 2 minus 1. 2 minus, you know, while I overthink that, let's just look at this. It's just a change of 1, right? Like to go from here to here is 1 unit. It goes up 1 as you go from negative 6 to negative 4. That's, I didn't need to do any more than that. Now we could, I don't really want to, negative 6 to negative 4, we could, so I noticed we have to break this up. We could do negative 6 to negative 5, find f prime, plus negative 5 to negative 4, find f prime. Let's go, so f prime is just the slopes, right? So the slope here is negative 1 and the slope here is positive 2, negative 1 and positive 2. So we can do this, negative 1 and positive 2. So this is a rectangle that has a base of 1 and a height of negative 1. And this has a base of 1 and a height of 2. And we get 2 minus 1, which is 1. Same answer either way, doesn't really make a difference. You want to be able to do both. So like, don't think, oh, I'm never going to do whatever, because you might. I'm gonna do two more, I guess. So 3 to 6. I don't know, that seems straightforward. 3 to 6. So 1.5, and then -3. So -1.5. I'm gonna write 1.5 minus 3 equals 1. What am I doing? Just tapping everywhere. 1.5 minus 3, -1.5. That was a very straightforward problem. 3 to 6 f prime. So this, let's do it with displacement. It should be where you end up minus where you start. And then maybe we'll do it the other way also, just to show that it works. 3 to 6. The annoying thing about doing it the other way though is, so all right, you end up at -3 and you start at +3. So -3 minus 3 is -6. -3 minus 3. So that's our displacement, is -6. It's the change in the function. You started at 3, you ended at -3, you lost 6. So that makes sense. We could also break this up. So let's do that. So we're going to go 3 to 4 with a slope of -3, and then 4 to 6 with a slope of -3/2. 3 to 4, I can actually, I'm going to do a weird thing. I'm going to write it here. So I'm going to do 3 to 4 of -3 dx, because that's f prime between 3 and 4, plus 4 to 6, -3/2. Then I'm just going to pick this up and take it with me. So this is, can do it, this. Okay, so this is the other way to do it. And this is, here we go. A rectangle that has a base of 1 and a height of -3, plus a rectangle that has a base of 2. So 2 is because of 6 minus 4. And a height of -3/2, which is -3 plus -3, -6. You're going to get the same answer either way. I'm going to do one more here, just because I feel like these look like they're going to be more work. I don't really know. Well, that's 5. 4 to 6. So trick question, sort of. This, you don't want to do this, right? 6 is bigger than 4. Flip the bounds, change the sign. So we're going to go negative of 4 to 6. I just always do that, and it's like you never need to learn like the other language of talking about these if you always are switching it and changing the sign. So 4 to 6, I bet we already did. 4 to 6, we got -3, so it's -3. So let's write that. Negative of -3 is +3. There you go. All right, I'm gonna stop this video to prevent it from being infinitely long. And then come back in the next one and finish this page. So I will see you there.